this is Jesse Rogers, and I'm going to show you how to do this optimization problem. So this is from a practice test. A company wishes to manufacture a box with a volume of 32 cubic feet that is open on the top and is twice as long as it is wide. Find the width of the box that can be produced using the minimum amount of material. Round to the nearest tenth if necessary. So the first thing I like to do with these kinds of problems is draw them out and see what it is that we're working with. So let's see if we can make sense of this. This is a box with an open top. So it's a rectangular box, not drawn to scale. I don't actually know what the dimensions of this thing are going to be yet. All I know is that it has a volume of 32 cubic feet and that it's open on the top and is twice as long as it is wide. So if this is the length and this is the width, let's say that the width is equal to x. Let w equal x. Well, then the length, it says that the length is twice the width. So that means that it's going to be 2x. Now, how do we find the height? That's the challenge because they didn't really tell us what the height is. They didn't say exactly this is the height, the way that they did for the width or the length. So we have to find it, we're going to find it in terms of the width. And the way that we're going to be able to do it is that we know that the volume is equal to the length times the width times the height for a rectangular box, right? So that's going to be what the volume is. And so if we know the volume is 32. And if we know that the length is 2x, and we know that the width is x, then the only variable we have left that's not in terms of x is going to be h. So we can solve this by getting everything over to one side. We have 2x squared h equals 32. And to get h by itself, we're just going to divide by 2x squared. So that cancels out. So we have h will equal 32 over 2x squared, which is 16 over x squared. So we've got something now that we can work with for h, and we'll be able to plug that into the area formula. Now, as far as area goes, the surface area of this is made up of, usually for a rectangle, it would be the formula for surface area would be equal to 2LW plus 2LH plus 2, let's see, which one are we missing? We need WH, right? So there's two kinds of panels for each, for each dimension. So we have a panel here, and there's another one over here. That one's the length times the height. Those are each the length times the height. And then we've got one for this front and one for this back. That's the width times the height. And then we've got one for the bottom, but in this case, there's not one for the top. So those are made up of the length times the width. So instead of there being two length times widths, there's actually only going to be one in this case. So we're going to get rid of that 2. There's only going to be 1. All right, so then now we're going to go back to this equation of the surface area modified for our open top box. And that, excuse me, that is what we're trying to optimize for. So we are going to make our substitutions. We have surface area will equal, remember that L is 2x. We'll get everything in terms of x. W is x. And we'll just do those substitutions. And h, remember that h is going to be 16 over x squared. So it's going to take a little bit to clean this up. We just got to combine like terms and work that out a little bit. So that gives us 2x squared. We have 2 times 16. So that should be 64. And then the x's can cancel out. We have an x on the top and an x squared on the bottom. So that would become 64 over x. Actually, I'm going to make it 64 times, let's make it 64 times x to the negative 1. All right, because we could take, that's x to the first, and that's x to the second. We do 1 minus 2. That's going to give us x to the negative 1. And then we're going to have another over here. This is going to be a 32, x to the negative 1. Those are like terms, and so we would be able to add them together. So then this becomes 2x squared plus, looks like 96 x to the negative 1. And now we can take the derivative. So when we optimize this, I'm going to clear out a little bit of room here. When we optimize for this, we're going to take the derivative, and it will be (4x), right? Because the 2 is going to come down, multiply times that 2, so we have 4x, and we subtract 1 from the exponent. Plus, actually that's going to be now minus, because the negative 1 is coming down and multiplying times 96, x, and we have to subtract 1 from that as well, so minus 2. Okay, so that's our derivative, and now because we're optimizing, we're going to set that derivative equal to 0. So 0 is equal to this. And we've got a couple ways to go about solving this. I would say let's multiply both sides by x to the second power, just so that I can get rid of that that x to the negative 2. And that would give me 4x to the third minus 96. I'll add 96 to both sides. And then divide by 4. So what we're really looking for here is the cube root of 96 over 4. So what I'll do is I'll put in 96 over 4 raised to the 1/3 power, which is the same thing as doing a cube root. Enter. So this becomes 2.88. And so that is the x. So we have x equals 2.88. And then from there, we're going to need to get the other dimensions. So we're just going to plug that into L, and we're going to plug that into H. So L, so this was the width. And then for the length is going to equal 2 times that number. So we just multiply it by 2. So we get L is equal to 5.77, let's say. And then H, to find the H, remember that formula was 16 over x squared. So we're going to take 16 over 2.88 squared. If you're doing this by multiple choice, as this problem is, then you don't have to necessarily be as exact. But if you're having to enter it in as a free response, you may want to go out more decimal places. You may not want to stop at the 8 there. You might have to keep going. And so that is going to be 1.92. Okay, so those are the dimensions that I get for this box, and it says find the width of the box that can be produced using the minimum amount of material. So I didn't really need to finish doing the other dimensions, but in case you wanted to know how to do that, you could still find them that way. So we have A, 2.9 is going to be our answer. All right, so I hope that clears up that problem. I know a lot of people have had trouble with this one, so let me know in the comments if you have any other questions about it or any comments.